is what a chord is. Well, a chord is just, yes. Oh, okay. It was rhetorical, sorry. I'm glad you're going to volunteer an answer. All right, a chord. I listed it all out for you. A chord, the long and short of a chord is it touches two parts of a circle and stays inside that circle. So this is an example of a chord. It touches here, touches here. It's got to go all the way from one side to the other. Remember, our diameter is actually a chord. It's a very specific chord because it cuts it right in half. It cuts it into a semicircle. It also, half of my diameter is my radius. The other two things we have on here is a minor arc. A minor arc is one that's less than 180, so it's usually a small arc, and we use 2 letters to write that. And we have a major arc. A major arc uses 3 letters. It's bigger than 180. Before I continue, okay. So, arc of a circle property. The big thing is, if I have a central angle. So if I have a central angle, and I know the degree measure of that central angle, that is also the measure of my arc, and vice versa. The big thing to take away from that is the fact that it has to be a central angle. Has to be a central angle. So that means it has to start smack dab in the middle and be 2 radii. Remember, two radii form that central angle. So it has to be that. And if it's true that that's true, then we know that that angle is the same thing as our arc. On the flip side, we're not going to be using this today, but just so we know, if it's inscribed, if we have an inscribed angle, so that means it's not starting at the center, it's starting at another point on our circle. If it's inscribed, that angle inside is actually half the degree measure of our arc. So for example, in that drawing, let's say that I have 100 degrees. My arc is 100 degrees. What was that? Oh, okay. That means my angle is going to be 50 degrees. So if my arc is 100 degrees, my angle is going to be 50 degrees, which makes sense because if I start equal, I have to get smaller and smaller and smaller to meet that, which means I have to get bigger and bigger and bigger. So if it starts in the center, it's equal to the arc. If it's way back here, it's going to be half that measure of the arc. So if you ever forget which one's half, just work with your hands. Just go, okay, halfway. Oh, that's bigger to meet it. That gets bigger. That must be smaller. So the one in the back is going to be your half. It's going to be your half one. Not part of the homework, but it's good to know now. So when we see it later on, it'll be more like review. Okay, our first chord theorem. And most of the work is already on here. So chords are equal lengths if and only if they subtend arcs of equal measure. What that's saying is exactly what's drawn here. If I have 2 chords, say I have chord AB and I have chord DC. If this arc is the same length as this arc, that means the 2 chords are congruent. We can go the other direction as well. If I had AB and DC and I knew that AC and AB were congruent, that would mean that these arcs would also be congruent. So it goes both directions. That's why we have here AB is congruent to DC. This double arrow thing is just like that statement we had if and only if. That means I can go both directions with it. I could say if these are congruent, if AB, if these 2 lines are congruent, then our arcs are congruent as well. They should have arcs on there. Let me go ahead and draw those in. Our arcs would be congruent as well. Just like if my arcs are congruent, my segments are congruent, or my chords are congruent. Do you have a question at all? Are you good?
Oh, sorry.
Okay. Oh, no, that's fine. Yeah. Okay, our second one is chords are equal length if and only if They are equidistant from the center of our circle. So AB is congruent to CD if and only if this distance is the same as this distance. So that works in both directions. If I ever draw two chords on a circle, and I say that this distance is the same as this distance, you can automatically know that AB is congruent to CD. And maybe I'll draw that in there. Likewise, if I know that AB is congruent to CD, I also know that this distance is the exact same. That's big, powerful stuff. Because that means all I have to do is tell you that this is congruent to this, and you know these are congruent as well. And we're going to piggyback on that in just a second, because we're going to talk about the next one. A radius is perpendicular to a chord if and only if that radius bisects the chord. So that means anytime I draw a distance from the circle to a chord, it automatically makes a right angle, and it also creates two equal sections. It bisects it. Yes?
That's not a radius, is it?
It's not a radius. A radius has to be from the circle to the end.
But just trying to say a part of the radius is perpendicular, right?
A radius is perpendicular to a chord if and only if that radius. So it's a radius to this. It's not the radius. It's a radius to.
Oh.
So it's basically our part of our radius
So
that
it's
does
not
it.
the circle?
It's not the full. It's not the circle radius.
Okay.
It'd be a radius of a smaller circle. But just don't get bogged down in the. Just know that this distance. Right. If this distance is a right angle, then it bisects it. And most of the time when we see this drawing, so we'll see this in action, which will make all this make a lot more sense. But based upon what happened here, I could come back up here and say that these are right angles because they're distances. And I could also say that CR is equal to RD, and I could say AQ is equal to QB, and I can also say that QB is equal to RD. And that's all based upon one fact, that this distance is the same as that. I get all that information. I get right angles. I get that these segments are congruent. I get that these segments are congruent. All from one fact, that the distance between them is the exact same. So that's pretty powerful. I can go from saying, hey, the distances are the same to these two chords, to knowing that this is congruent to that, and that this is a right angle. And it's important to know that. Okay, so this stuff makes more sense when it's actually in practice. So the first thing we're going to do is we're going to determine what A equals. So this is going to go back to that first property. All of my chords are congruent. So if this is 81, Mike, what is the measure of this chord? Or not chord, but the arc? 81. 81. Yep. And then this arc is also going to be 81. And how do I find this arc then? Mazin?
360 minus 81 times 3.
Yeah, 360 minus 81 times 3, or 360 minus 81 minus 81 minus 81.
What's
And
81 times 3?
what was that?
What's 81 times 3? 243.
So what do we come up to?
117.
Is that what you got?
87 degrees?
Ooh, we got 87 and we got one. What do other people get?
117. 117.
It's 117. Just double check your math. So that's 117, because that would be 360 minus 3 times 81. That's going to equal one. That looks like 127 or 177. It should be 117. Which means A equals what?
117.
117 as well.
How do we even know that?
Is a property that we did. The very first one we did.
You said that angle equals. I mean, how do you know A is the same?
We're just based upon the drawing, we're just going to assume it's the center. And we know it's the center because A is labeled by it. You only label the center. So if a point is labeled in the middle, it can be assumed that that is your center. Yeah.
And then it would be like a dot, just like off a little, like not in the center, but like.
I would make it very clear that it's not the center. If it was on the test, I'd be like, note that A is not the center of the circle. I would make well known that it's not the center, because otherwise I'd be just trying to trick you, basically, and that's not the point of math. Okay, in the picture below, DE is congruent to JK. Okay. Well, that's a whole bunch of information right there. So JK and DE are congruent. So based upon them being congruent, I can immediately, it's hard to actually write that down, so we just know that DE is congruent. So that means that JZ is congruent to ZK, which is congruent to YE, which is congruent to DY. I also know, because those two chords are congruent, that YZ is congruent to XZ. I might not need all those facts, but it's always good to start thinking about all the stuff you know when they give you facts. All right, so DE is congruent to JK. I did all that just based upon that. JK equals 30. So JK, J to K, equals 30. So what's the length of JZ? Yeah.
Beyonce.
50, it's not Beyonce, it's 15. That would be 15. This would be 15. This would be 15 as well. All right, JX equals 17. So J to X. So I don't know if you could see it on yours.
Yeah.
Oh, you can? Oh, good. Yep. So that would be 17. Well, here's my question. What is this line called that goes from the center to the edge of the circle? Yeah. It's called the radius. Am I allowed to write the radius anywhere I want to?
No.
Why not? Could I write a radius here?
Oh yeah, measurement.
Is it still 17 here?
Yeah.
Is it still 17 here?
17 everywhere.
Yeah, I'm telling you that right now because, gentlemen, if you can't stand sitting back there, you'll move up here. That's your warning. I'm telling you that right now because in the homework, you're going to have to draw your own pictures. And so you're going to have to decide where you draw your radius, okay, to make it advantageous. And I'll show you what I mean in the next problem. Okay, so that's a radius. That equals 15. I need to get xy. Well, xy is the same length as xz, so I really just have to find xz. But do you see this right triangle I created?
Yeah.
With two sides? If I have a right triangle with two sides, I'm going to go ahead and draw that off to the side. I'm going to say, hey, I got this triangle. I'm going to draw it bigger than that because everyone needs to be able to see it. I'm going to draw that triangle. That's 90 degrees. And this is 15. And this is 17. Well, to find that missing side, I'm just going to call it, well, let's just call it what it is. So this is Z. And this is X. So to find that, I'm going to do 15 squared plus that X, whatever length XZ is, squared equals 17 squared. And I'm just going to kind of show you the work for it, possibly, because I don't feel like taking out my calculator, but maybe I'll have to. All right, so you're going to come up with 225 plus that XZ line squared. That's going to equal 289. I'm going to subtract 225 from both sides. So you're going to come up with XZ squared is going to equal 64. Then I would take the square root of both sides, and I'm going to see XZ equals the square root of 64. Well, I don't want to write the square root of 64. I want to write equals 8. So since XZ equals 8, that means XY also equals 8. So if this guy is 8, that means this guy is 8 as well. So our finished answer is X, Y equals 8. Any questions on any one of those steps? No? Okay. The last one represents kind of those last questions that are going to be on your homework that you have to draw it yourself. So it says, in circle C, chord AB is 12 centimeters away from C. So first I'm going to draw that center of that circle and I'm going to call it C. So draw a circle and put a center and call it C. Now it doesn't say where I have to draw the chord. So I'm just going to draw a chord that goes across. And my advice to you is don't draw a diameter. Alright, because it's the hardest one to see stuff on. So, not to mention this has to be 12 centimeters from C, so it couldn't even be a diameter. So I'm just going to draw a chord kind of up here. Just anywhere I want to, just up here. So that is my chord. I'm going to call it AB. Well, the distance from AB to C is equal to 12. So maybe I'll do a red, let's do a purple. So this distance here is going to be 12. Well, since it's a distance, this is going to be a right angle. So without even looking at the question, I know that this is a right angle, where A to whatever the center is, and the center to B are both congruent to each other. Alright, the next thing I'm going to note is the radius of C is 18 centimeters. Here's my hint when drawing your radius. You could draw your radius out here and say that's 18, but does that interact with my drawing at all? No, it doesn't. So my advice to you is when they tell you a radius, try to create a triangle because we know how to work with triangles. And our radius is 18. So just where I drew my radius went from unuseful to a right triangle that I know two sides of. And I need to find AB. Well, if I find this distance, multiply it by 2, I have A to B. So we just created a right triangle. So I'm going to go ahead and draw that right triangle I just created. I have a right triangle that's height is 12, hypotenuse is 18. I just need to find this missing side. So we're just going to say 12 squared plus x squared equals 18 squared. So that's going to be 144 plus x squared. That equals, I always forget 18 squared. That is going to be 324. 324 minus 144, we're going to come up with x squared is going to equal 180. And so I'm going to take the square root of both sides. And we're going to see that x equals square root of 180. But 36 actually goes into 180. So we're going to whittle this down to square root of 36 times square root of 5. 36 times 5 equals 180. Which is going to be 6 times the square root of 5. So this x right here is 6 square root of 5. So this right here is 6 square root of 5. Which means that this is 6 square root of 5. So that means that AB is going to equal 6 square root of 5 plus 6 square root of 5, because there's two of them that consist of it, which is just 12 square root of 5, and I'm done. All right, your homework is going to consist of the first few